Hello everyone and welcome back in our foundation engineering class. We are going to continue chapter number 5, settlement of shallow foundation. So this time we are going for a method using strain influence factor. Okay, what is strain and how it can influence the settlement. Okay, so this part is using some influence factor, as the name indicates, to propose an estimation of settlement. So there are two solutions. The first one is the solution of from this reference, okay, in 1978. And according to this solution, when you have this kind of footing, this configuration, the footing is here, the embedment, and the depth, okay? So the settlement, the load here will affect, will vary. The effect of the load is changing according to the depth, like this, okay? And at each depth, you will of course have this influence factor, okay? It is the same illustration. Similar illustration is shown here, but we are going to see how to read this chart. So this is the equation, the formula according to this reference, and each of the parameters here is important, of course, but the influence factor is this one, this IZ, okay? And it is showing here how IZ is changing according to the depths. So the IZ strain influence factor, this one. C1, it is this one. This one is related to the depths of the foundation, means the embedment, okay? So that fact is a factor correcting for correction for the embedment, DF, okay? And you can estimate it using this equation, 1 minus 0.5 Q, which you divide by uh, this Q bar and Q again. So this can easily be estimated, okay? C2, this one, that one is related to the creep in the soil, okay? And given by this equation. So how many times in the year the creeps happen, then divided by 0.1. The Q bar here is stress at the level of the foundation. The level of foundation, you can see it here, I think. Stretch here, okay? They down, the level of foundation, what is the stress? Which is different for this Q. Okay, this one is just the overburden, like recharge, okay, which is easy, gamma multiplied by df, okay, effective stress at the base of the foundation. So I think the difference is very easy to understand. This Q bar is the load coming on the footing, okay, stress at the level of the foundation. So if you have these two, it's easy to obtain C1, yeah, because in the equation of C1, these are included there, okay? Okay, and ES, I think you know already, it is a modulus of elasticity of the soil, yeah? So everything is here. So as you can see, the most difficult parameter or the most uh, uh, the key parameter here is this IZ, the strain influence factor. Okay, this delta Z is just like the variation in the depth. Okay, so the this strain influence factor is changing according to the depth. Okay, and it's changing also according to the type of foundation. For example, you have here for square footing, and this one here, this figure is for strip footing. Okay, so if you are, for example, at the ground level, or you are at Z1 with 0.5 times the the diameter of the footing, or let's say the side of the footing. In the case of square footing, Z2 is the limit, as you can see, where the this IZ is becoming 0, and this one is 2 times B. Okay, the meaning of this is that after this, deeper than 2 times the pile diameter, let's say sorry, footing size, there is no more effect of that load. That is the meaning. Okay, but this is in case of square footing. For strip footing, Z1, the value of Z1 is B, not 0.5 times B. And the value of Z2 is 4 times B. You can see the difference, okay? So let's continue. Keep this here and keep this equation here. So the variation of this, as you can see, with depth of the influence factor for square, this footing, square is sometimes similar to circular foundation. And in the case of uh, strip footing, but L bar B, the L being the length of the foundation, B is the width of the foundation. It's larger than 10. So these are given in this figure, okay? We already explained that. So IZ, this diagram for example, this one, between 1 and 10 can be interpolated. Do you understand? It means what we have right now is the IZ for square footing and the IZ for strip footing with ratio L bar B larger than 10. Okay, as you can see here, it is L bar B, it is 1, L bar B, it is 10 here. Okay, what about when you have a footing with ratio L bar B equal 5, for example? How will you proceed? Okay, so we have to do interpolation, okay, to obtain that. Hoping that everyone understand what is interpolation. It means maybe by proportion. If 1 gives this value and 10 give this value, what value 5 will give, something like that. Okay, so the maximum value of this IZ, as you can see in this case, it is this value, maximum, the maximum. At the surface, it's starting from here and it reaches the maximum, then it decreases again. Same here, at the surface, the ground level, or let's say at the foundation level, it starts here then comes here, the maximum, and it goes decreasing. Okay. So this maximum IZ is happening at the depths Z1. Okay. Z1, Z1. Z1 doesn't have the same value for each type of foundation. Okay. And then at the Z0, everything becomes 0. Okay. Yeah. So this maximum value, how can we calculate it? How do you estimate the maximum value of IZM? By using this equation. Okay. It is obtained from, I think you know already, Q bar, which is the stress here from the load at this level. And Q is just the surcharge. Okay. So for each foundation, means we can easily obtain the IZM, the maximum. Okay. And in this equation, we can see this one, QZ prime 1. You can see it here, which correspond to this level, okay? In each case, corresponding to the depths where the maximum IZ is happening, okay? So this is effective stress at the depths Z, um, Z1, okay? Before construction of the foundation, effective stress, before building the footing, okay? I think that one is easy for everyone to understand. What is effective stress? The effective stress changing vertical, it better to precise, vertical effective stress is just using the weight of the ground. Okay. Yeah. And you have to do minus the water pressure, of course. But I think if you are here, you should be able to understand that from soil mechanics 1. Okay. But the most important thing is that it is before the construction. So, sorry. There are some ways to estimate the value, some relationship to estimate the value of IZ. Okay. At 0, Z equal 0, Z equal Z1 divided by B, Z equal Z2 divided by B, and that for rectangular foundation. Okay. For Z at 0, it means this value, for example, 0.2 or 0.1. How to estimate it for any rectangular foundation? It means from this to this, between these two. For example, when you have L bar B equal 5, which is like middle between this one and this one, okay? And you are wondering, okay, how can I estimate the value at the footing base level here? In this case, it's 0.1, in this case, 0.2, okay? So as we said, we have to interpolate. And for interpolation, we are giving you here the equation to do that, okay? So you can see that everything will be same except this IZ. So if you have a footing, rectangular footing, and the ratio L divided by B is 5, how will you do? This is the equation that giving you IZ at